Assalamu alaikum students, welcome to another lecture of Slate, and this is me, Khawaja Yasin, and let's study chemistry. So, when we talk about O-levels chemistry, we all know that the chapter of moles is the trickiest one. Most of the students struggle in this chapter because this chapter is a part of your P1, P2 and P4 if you are a student of GCE, and it's a major part of P2, P4 and P6 if you are a student of IGCSE. So the concept of moles is the most important one. अगर आप लोग moles को skip करते हैं, you will make things difficult for you because it is a short thing that you will get and multiple questions from this chapter in your exam. So we in these videos we will discuss various topics of moles so that after every video you cover one concept. So today we are going to talk about the concept of empirical and molecular formula in moles. We will be discussing a few questions, we will be discussing the differences, and we will be discussing the formulas. So after just solving 3 questions, I assure you that the topic will be the easiest one for you. So let's talk about what do we know about the molecular formula first. So molecular formula. This is the formula that you all know about. This is the formula which we normally use when we are expressing or writing a formula. So if you have to define the molecular formula, you will just say the formula that contains, or I can say that shows the actual number of atoms in a molecule. For instance, if you're talking about water, what do we know about the molecular formula of water? That is simply H2O. That's the molecular formula. By now, if you have studied organic chemistry, you would know the molecular formula. At first, if we talk about methane, that's CH4. If we talk about ethane, that's C2H6. And most importantly, especially for the bio students, you must know that very well. आपके लिए it's an easy thing. You must have studied in your grade 8. We will talk about glucose as a prime example. Glucose is C6H12O6. So this is the molecular formula of glucose. The formula easily tells you that a glucose molecule has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. So this is the molecular formula of glucose. Again, this is the one we have been using since forever. But now let's jump onto the concept of empirical formula. What is empirical formula? Empirical formula is the one that shows the whole number ratio. Let me write it first for you. The formula that shows the whole number ratio of atoms in a compound. Now, students, what you have to note and prioritize is the most important thing. A, whole number, and B, ratio. These two concepts are very important. A, you need to know that whatever you're doing, it should be a whole number. And B, it should be a ratio. For instance, let's talk about glucose here. Glucose was C6H12O6. So let's make a ratio of this. So ratio, we have 3 elements involved: carbon, hydrogen, and oxygen. So how many atoms of carbon do you see here? 6. Hydrogen, 12. Oxygen, 6. You all have studied mathematics. Whenever we discuss about ratios, we cancel them with a simple whole number. So if we divide all three by 6, you will get 1 ratio 2 ratio 1. This is the simplest whole number. But it's a very common mistake. I guess most of my students do it, and I have to remind them again and again that this ratio is not the final answer. The final answer is when you incorporate these values into a formula. So 1 mole of carbon, 2 moles of hydrogen, and 1 mole of oxygen. CH2O. This is the empirical formula for glucose. For instance, we talked about ethane as well. Ethane is C and H, just it's a hydrocarbon. We will study that in detail later. So it has 2 atoms of or moles of carbon and 6 moles of hydrogen. What would you do? You take the simplest number, which is 2. You divide both sides by 2, and you end up getting a ratio that is 1 ratio 3. So your empirical formula would be CH3. The formula should be this way, not just the numbers. I repeat, that's a very common mistake. So A, we know it's the simplest whole number ratio. Now, what common mistake? That a common hurdle, I would say, that if you look at this empirical formula, this does not tell you that this is the empirical formula of which particular compound. For instance, if we have a compound which has the molecular formula of C12, H24, O12, you make a ratio out of it, and this would end up going the same way. 1 ratio 2 ratio 1. And the empirical formula again would be CH2O. Now, this is the confusion problem. How would you find out that which molecular formula or which compound does this empirical formula belongs to? Because both give the same empirical formula. So in the exam, you will have to find out the molecular formula as well. There's the bad news. You would never be given the empirical formula. You will have to calculate the empirical formula yourself, and then you will have to further calculate the molecular formula. But again, it's not a very difficult calculation. Simplest 2 equations, 2 formulas that you have to keep in your mind. So molecular formula is equal to N into empirical formula. Now talking about this N, this is a multiplication factor. I told you in a question you would not be given the molecular formula, and especially you would not even have the empirical formula, mostly. So you don't have this value, you don't have this value. You also don't have the N value, but you can calculate N. How would you calculate N? N equals to molar mass, or you can call it the relative molecular mass, or you can further call it molecular formula mass. These are all similar values. They mean the same thing. In a question, you can be given the value in either of the ways. And you divide this value by empirical formula mass. By this equation, you will get the value of N. You will get a number. You will multiply that number with the empirical formula, and you will find your molecular formula. So let's say that you get a question. You found the empirical formula. And in a question, they say the MR of the compound is the similar compound, the glucose one that we're talking about, is 180 gram per mole. Okay, we have found the molecular formula, molecular mass now, which is the MR, which can be the mass of 1 mole of the compound. So we are just going to put this value in this equation. So at first, we'll find the value of n. So n equals to, what is the MR? 180. Now, what is the empirical formula mass? You will look into the empirical formula. Now we have to calculate the mass of the empirical formula. So again, carbon is 12 in the periodic table. Hydrogen is 1. So 2 into 1 plus oxygen, which is 16. So this is 14 plus 16, that is 30. So this is the empirical formula mass. So let's incorporate this value into the formula. So 180 divided by 30, that is 6. So the multiplication factor is 6. Now, molecular formula is equals to n into empirical formula. So obviously we know the empirical formula that we've calculated here, which is CH2O. CH2O. And you multiply that by 6, the value you just calculated here. So you're going to multiply it by 6. So that becomes C6H12O6. So this is glucose. And this is not the compound that we made here. So that is something we know about. So that is the concept. But again, when we talk about moles, you need to practice it. For moles, the more you practice, the better you become, the better you get. Because okay, these were the two formulas. Let's solve this question first. Find the empirical formula of an oxide of magnesium consisting of 0.32 gram of oxygen and 0.96 gram of magnesium. So whenever I was saying that glucose contains 6 moles of carbon, 12 moles of hydrogen, there was a reason I was using the term moles here. Because even in an empirical formula, here, if you just talk about this, which is the empirical formula where CH3, we have 1 mole of carbon and 3 moles of hydrogen. So moles, the term is moles. So even when we are doing the percentage, the ratio, you're going to calculate the moles. So let's do step by step. Which two elements are involved? Oxygen and magnesium. Find the empirical formula of an oxide of magnesium consisting of 0.32 grams of oxygen and 0.96 grams of magnesium. So oxygen and magnesium. These are the two elements. Now, as I repeatedly kept on saying the term moles, so we need to find out their moles. The formula of moles, when you have a mass given, N equals to mass divided by MR. Ratio, again, the same formula. MR or AR, that is something you can use alternatively. AR for the elements, MR for the compounds, but both can be used. So what is the mass of oxygen that we have? 32.32, I mean. 0.32 divided by 16, which is the AR of oxygen. Ratio 0.96 divided by 24. You can see the periodic table for the atomic mass values. That's not a difficult task. But now you have to do the calculation. So let's calculate the values. 0.32 divided by 16. 0.02 ratio 0.04. So these are the two values that we've found. But as I initially focused on, that it should be a whole number ratio. We have calculated the ratio. The ratio is the right one. But we need to jump towards whole number. So if I write the steps, step number 1, calculate moles. Found the value, this is the value for moles. Step number 2, divide all the values by the smallest value. So which is the smallest value? 0.02 is the smallest value. 0.02 and 0.04, we divide both by 0.02. Now, why do we do this step? Let's see. Dividing it by the same value, you get 1 ratio 2 here. So this ratio is a whole number ratio, but that's not the final answer as I said initially. This is just a ratio. You need to put these values into these. So this becomes Mg2O. This is your final answer. This is the empirical formula. That is one way. Now let's talk about the other one, where students mostly do get confused. An oxide of sulfur consists of 40% sulfur and 60% oxygen. Take the total 100% to be 100 grams. That is something which is written, but let me explain. Whenever you get percentage and you have to find the empirical formula, know something for sure, that we assume it's a rule. We assume that 100% equals to 100 gram. Why do we do that? Let's see. So we have two elements that are involved. A, we have sulfur. B, we have oxygen. Now we have percentages, we don't have masses. But here we just said percentage equals to mass. So if I have 40% of sulfur, which means I have 40 grams of sulfur. So I will just calculate step one, I'll calculate the moles. N equals to mass over atomic mass, relative atomic mass. So for sulfur, we had 40%, which means 40 gram divided by 32, which is the AR of sulfur. Ratio 60 grams divided by 16, which is the AR of oxygen. Let's calculate the values. 40 divided by 32, this is 1.25. 60 divided by 16. Now again, we still do not get the values in whole number. Just see, let's for instance, if I incorporate the values, the compound would look like S1.25, O3.75. This is a formula you would have never seen in your life. You always see the formula in whole numbers. So obviously that's a wrong one. So again, we will divide by the smallest value. 1.25 is the smallest value. So 1.25, and we'll divide both by 1.25. And ultimately you will get 1 ratio 3. And that is how the answer will be sulfur trioxide, SO3. Now let's do a proper question here. This is the last question for today. I hope after this one, it will get easier for you. Determine the empirical and molecular formula of, of Christoyl asbestos, and they've given you the percentages of magnesium, silicon, hydrogen, and oxygen in the compound. And they've given you the molar mass of the compound, which is 520.8 gram per mole. Perfect. So initially, we are going to calculate the empirical formula. Let's do that. Which elements are involved? We have magnesium, ratio silicon, ratio hydrogen, ratio oxygen. These are the 4 elements that are involved. But again, when we are given percentages, know for sure that that percentage is the mass. And for instance, even if you don't have the percentage of oxygen of one of the compounds, what will you do? You will add the 3 percentages and subtract it from 100, so that the whole sum is 100. So magnesium, let's talk about magnesium's percentage, that is 28.03. Ratio silicon's percentage, that is 21.60. hydrogen 1.16, oxygen 49.21. We divide the values by their AR values. Again, you will find that from the periodic table. Magnesium is 24, silicon is 28, hydrogen is obviously 1, and oxygen is 16. So let's divide the values. I can see the trend. It's very basic. 28.03 divided by 24, that becomes 1.167. That's the percentage? Yeah, that's the percentage. 21.60 for silicon, and I divided by 28. 0.771. Hydrogen, it's very simple. 1.16. 49.21 divided by 16. 3.07. Now, which is the smallest value? We see that 0.771 is the smallest value. We divide all the values with the smallest value. And let's see the value that we get here. It's better that I solve it with you so that you can see how much time will it take you to solve the question. Even I'm doing the question for the first time. So see what's going to happen now. I'm going to get the value 1.5 here. This is obviously 1. This will obviously be 1.5 again. 3.07 divided by 4. 3.98, we consider it 4. Now, I have done this step, but then you see there is another issue here. These two values are not whole numbers. Now, this is a very important step. Even after doing that in the above questions, we got the whole number values. Then we are going to multiply all the values. Multiply all the values with the smallest number to make whole again. So let's say if I multiply by 1, it's going to be the same. Let's try it with 2. So if I multiply all the values with 2, I guess we will meet the end result. So this would be 3 ratio, 2 ratio, 3 ratio, 8. Now that is the whole number ratio. So the compound would be something like 3 moles of magnesium. What do we have? Silicon. 2 moles of silicon, 3 moles of hydrogen, and 8 moles of oxygen. Now this huge formula is the empirical formula. They want us to find the molecular formula. Let's see. It's the same formula. They have given us the molar mass, which is 520. So at first we need to find the value of N. So N equals to molar mass divided by empirical formula mass. Molar mass, we know it's, what do we have it here? 520.8 divided by empirical formula mass. Let's calculate the values. 24 into 3 plus 28 into 2, plus 3 plus 16 into 8. Let's see what's the mass of the empirical formula. So 24 into 3 would be 72 plus 56 plus 3 plus 128. So let's add all the values. 128 plus the answer is 259. Let's see what happens. So if I divide it by 259, which is almost 260, but let's see. 520 divided by 259, that would be 2.007. So obviously the value is 2. The N is 2. What will we do? Let's wrap it up. So molecular formula equals to N into empirical formula. The N value is 2 multiplied by the empirical formula, which is Mg3 Si2 H3O8. Multiplying the value, the final answer is Mg6 Si4 H6O16. This is the molecular formula. So students, we have discussed the empirical and molecular formula today in various ways. We have found out that how to calculate through percentages, through masses, and we've seen the added step when you don't get the value in whole number. So that's all about the empirical and molecular formula calculations. Thank you so much for being here with us. We will come up with more topics from moles and from the whole chemistry. Thank you so much, and Allah Hafiz.